Hello everyone.
Hi sir.
In this video, we are going to discuss about design thinking approach to electrical vehicle motors speed controls. The electrical vehicles are playing essential role in our area because most of them we are using electrical vehicle for their own vehicles. And the topic of this electrical vehicle based on the motor speed control is based on stator and rotor windings because these two windings are playing a major role for speed control. Because while considering this stator and rotor control, the stator control is based on the number of windings, and based on the number of windings, it just induce the electromagnetic field so that it may refer the rotor. The rotor is based on the rotation, number of rotation of the concerned motor. Based on the rotation of the motor, it just induces the torque of the particular south and north portion of the magnet, so that it will induce the EMF throughout this speed control of the vehicle. And most probably we are using here brushless DC motor. The main purpose of this brushless DC motor is based on the position of the rotor portion, the stator winding has been operated. Let me see how these operation will be enabled for design thinking 5 stages: define, ideate, prototyping, testing process. Let me see how these design thinking process will be processed.
Okay, let us see about the empathy part of the topic. In the real world electric vehicles, the applications, the driver needs a smooth acceleration, quick torque response, and stability. Acceleration, torque response, and the stable speed, even riding in the upwells or carrying different kinds of loads. If the vehicle experiences the smooth acceleration and the smooth slow response and the instability, it reduces the driver comfort and the overall efficiency.
Position of the rotor, that the speed has been measured.
But the same time, e-vehicles rely on the batteries, which has the powerful efficiency and it extends the battery life. At the same point, industry point, the manufacturers which has the reliable, safe and energy efficiency, by understanding the needs of the drivers, maintenance team, which ready the smooth response and which helps to perform the good performance and efficient usage.
Now I am going to say about the design. In this definition, we identify the main problem of the system. In the electric vehicle, the main problem is to maintain the speed steady and the torque even if the road condition changes. Sometimes the vehicle goes uphill or downhill, or sometimes the load of the vehicle changes when the passenger settles inside the vehicle. So because of this, the speed changes.
Once the speed has been changed, the proposed rotation has also to be monitored. So based on the rotation of the motor, the speed also reduced.
So that we have designed the system.
Process to be monitored based on the amplifiers. These are amplifiers to make it out the data to be a proper value.
So that we design the motor control system, which maintains the speed steady even when the condition changes. So we have made a closed loop control system. It can also continuously measure the speed when they compare to the DC.
So the purpose of closed loop is to get the feedback of the users so that the speed and consumed power value has been revised.
This makes it stable, efficient, even compared to the electric vehicles in real conditions. Okay, now I am going to discuss about the ID part. So first we solve the design problems. There are a lot of control strategies to be evolved, PDE and DCDIL. It's a kind of a motor. It's a technical device to solve or rectify the motor design or motor efficiency works or etc. At the same time, it helps to achieve the voltage and current levels. By achieving the voltage and current levels, the motor speeds and the motor acceleration to be smoothly easily. Nowadays, we use the BCDML motors because that's a modern motor. It has a high efficiency because it made up of under the closed loop condition. There are two type of loops, so open loop and closed loop. So closed loop is a difficult one because it will take the feedback directly from the sensors. But in open loops, the sensors they are not directly infused into the motor.
Some of the sensors and amplifiers are used to sense the elements of the particular dark experience this period, so that the rotor has to be monitored.
So it is easy to understand because we use closed loops. There is some difficulty to project the sensors as directly to take the feedback resistors or anything, voltage, current, etc. By using the open loop, the efficiency of the motor to be good, and we can overcome the problems. So now I'm going to explain about the prototype part of the design thinking. We all know that in the prototype we are going to build a working model of the system of our idea to check how it works in the real time and to what are the things that are error and we can correct them. So in this we are building a control system. So we are using the BLDC motor like the brushless DC motor and motor driver and many sensors like speed sensors like Hall sensor and microcontroller. So the main idea is to build a closed loop control system. So in this closed loop control system, the system continuously monitor what are the actual speed of the motor in the using the sensors. So we can manage and compare it with the required level. So now we see any error occurs. When the error occurs, that time that PID controller is coming in. That and that after the
Personal integrative and derivative controllers, especially for generating errors of motors, so that we can able to fix the errors by using this proportional and integrative derivative controllers.
So now this PID controller is adjusting the BMW signals that are sent to the motor driver. So when these signals are sent to the motor driver, that will make the speed of the motor to be correct and set to the regular. So before implementing all these in the hardware, we can use simulation like MATLAB. So it also avoid the damage of the
check the rotation and
how to test and how to
motors has to be constantly put in the MATLAB.
so you can avoid the damage of the physical components. So in this prototype phase, we learn about the theoretical knowledge of the control system with the real-time application, how it works and how it implements.
So next I'm going to explain about the final stage of designing approach, which is testing stage. So in the testing stage, we can check how the systems work under different real-life applications, which includes the situations in changes in load, sudden acceleration and braking. So we can mainly focus on important factors, which includes how.
So it is mainly based on position and velocity acceleration process, so that the finalized value to be approximated based on the user's plan.
So we mainly focus on important factors, which includes how quickly the system responds and how long it takes to become stable, and also how accurate can it is on a long time. So and also collector is used, which makes sure that the motor runs smoothly without any unwanted oscillations. So to conclude, if all the tests are successful, we can make sure that the motor of the system is in stable speed and current.
So we shall discuss about various training stages, and we are using this electric vehicle nowadays for autonomous vehicles. We hope in future it may be revised multiple number of users. Thank you.